Alrighty, everybody, let's look at example 2 now. Right off the bat, they tell us that we are going to get two triangles in this, and you can see these two triangles at the bottom of your page. So I hate to spoil the surprise and say, oh my gosh, surprise, two triangles. But the more important thing is that we talk about how we got these two triangles. All right, so let's start with what they gave us. I know I'm going to get both of these triangles, but let's take a look at what they gave us. They gave me angle A, side A, and side B. That means, right off the bat, we can find angle B. And we're going to find angle B by setting up our law of sines. So we're going to say the sine of angle A, 55.3 degrees, over the length of side A, 22.8.
Look at my glass eyes.
Shh, sweetie. Sorry about that. My granddaughter walked in. She's cute as a button, but still had to tell her to be quiet so we could finish this up. All right, so we did the sine of angle A over the length of side A is going to equal the sine of angle B over the length of side B. All right, so now what we're going to do is we're going to solve for B by cross multiplying. So I'm going to say 22.8 times sine big B equals 24.9 times the sine of 55.3. Divide both sides by 22.8. So the sine of angle B equals 24.9 times the sine of 55.3, all divided by 22.8. Alrighty, because I'm trying to find an angle, my question is, does this triangle even exist? Because as of right now, I only know that there's two triangles because the problem told me. What if the problem didn't tell me? What if the problem just said solve for the triangle and it didn't say that there are going to be two triangles? Well, to see if it even works, let's take the right side of my equation, plug it into my calculator, and see what it gives me. So we know the sine of angle B is going to equal 0.8978678. And that works. That lets me know, hey, angle B exists in this triangle. Angle B can be an angle of the triangle because the sine of B is less than or equal to 1. If we are less than or equal to 1, the angle exists. So what we're going to do is we're going to find the inverse sine of this to find out how big angle B is. So find the arc sine or the inverse sine, and we are going to get B is about, it's not exactly equal to, it's about 63.9 degrees. All right, so we know it exists and we know it gives us an angle. Now the question is this the only triangle? Is this the only angle that it works? Well, what this is saying, remember, is that B has a reference angle of 63.9 degrees. Well, where else might sine have an angle of? What other angle gives me a sine value that's positive? And that would be if this reference angle was also 63.9 degrees. So to find that angle, what I'm going to do is I'm going to do 180, because we are up from that, subtract 63.9, and we get a value of 116.1. So that could be my potential second angle. Now the question is, do these angles actually, are these both good angles? Well, we know this one is, and this one, my final check is going to be to see if these are both viable angles, is if we add angle A plus angle B, it needs to be less than 180 degrees because we need some room for angle C. So for my first one, if we do 63.9 plus angle A was 55.3, we're going to get, where's my calculator? Hold on. So I add angle A and angle B, that's 119.2 degrees, which leaves that smaller than 180. So this A and B combination is good. We'll get a triangle with this B1. Well, let's try B2. Let's take B2 and add it to angle A. So 55.3 plus 116.1. Is that less than 180? And that's going to give me 171.4. That's less than 180. So B2 also gives me, is also a viable angle. So we've got a triangle here on the left where we know angle A, angle B, side A, and side B. And if you look, it's this triangle right here. And then you can use your law of sines and cosines to find the angle C and side C. Not cosines, you're not using law of cosines yet, just law of sines. And then on this other one, here's my other one, 116.1, 22.8 again. We can figure out the length of B. There's my length of B at 24.9. Now you can use the law of sines to figure out big C and little c. Actually, we're not going to use the law of sines to figure out angle C2. We just know all three of these angles add up to 180, and then you can find the missing third side. Alrighty. So the key on this is if you are using sine to find an angle, after you find if the angle exists, and I know it exists because it'll be less than or equal to 1, when I get a value, see if there is a second angle value that works. And to find that second angle value, you're going to take the angle you have, subtract it from 180, and double check and see what that gives you. Then you test to see, do both angles work in a triangle? So add the two given angles together, or the angle they gave you plus the angle you found. Is it less than 180? Take the angle they gave you, add it to the angle you found. Is it less than 180? And now you know we've got two triangles. Because what we're going to see in the next example is that I'm going to do it with you, is that if you turn the page and look, you can see that there's going to be one triangle only for this side. And we're going to do that in our next video. So come to class with your questions, and I'll see you when I see you.